Good. It has been started. Sharing my screen with you. Okay. Here we are on this file, and I had circulated this file with all of you where we have the portfolio of the various different clients based on their requirement. We had built the portfolios. Some of the people who are conservative in nature, their allocation was made accordingly. Some of the people who are very balanced in nature. Now, conservative, balanced, and aggressive is denoted in terms of risk taking capacity. Some of you might be having a very good risk taking capacity. Those would be the aggressive investors. Now, we had found the monthly return as well. I had told you that how to find the yearly return from that too. Up to that point of time, I guess we had done it. But we are meeting after quite a few number of days. So I would just give you the brief overview about the file again in a minute, and then we'll move forward to finding the value at risk by using some Excel functions, which gonna be very, very easy. Okay. Uh, in this file, we had the monthly return of various portfolios. Now we had found the portfolio returns by taking the three type of an assets. All the three types of an assets were given to us in the data file here, and we had the return from each and every asset class there. One was a bond, another one was equity, and third one was cash. We had the returns in all three categories, and we had given the weights based on their percentage allocation. Let me use the magnifier so that you're able to get it in a better way. Say in the first one, the weight was 55 percentage for bonds. So what we had done was we had found this return by giving 55 percentage weight to the return of bond. So we went over there, we had selected the return of bond in the first month, and we had multiplied that with 55 percentage, or I may just write 0.552 in decimals, plus 30 percentage weight was given to the return of equity, and 15 percentage of weight was given to the return of cash. So here is how the equation was looking like. Weight 1 multiplied by return 1 plus weight 2 multiplied by return 2 plus weight 3 multiplied by return 3. So you get the portfolio return for that month, because each and every asset class needs to be given a specific percentage of the weight in terms of return, right? So if you add this three, you get the monthly return, and those monthly return on compounding basis, we had found the yearly returns too. And the procedure to find the yearly return was very simple. We had just added 1 to the monthly returns. Now, this is not the simple average of return we have taken. This is not just a simple addition of the monthly return. No, you cannot just simply add the monthly return so you get the yearly return. No, because it's compounding in nature, right? So that's why we were supposed to find the yearly return by applying the geometric mean concept. That means it was multiplying with each other. Say if I give you one more example, uh, 0.14 percentage of return, say on 1000, right, would be, or 100 would be 0.14, right? So your portfolio amount would reach to 100.14 after the end of the first month. And the second month's return was on this amount, was not again on 100. So the second return you get, no, which is 0.17, that is on the portfolio amount of 100.14. So these returns are interrelated with each other. They are not exclusive. You cannot take the average of it. So what we had done, we had added 1 to each and every monthly returns. And here we had applied the product, which was the multiplication of all the returns. And from there we had done -1. So we got the return of 8.8 percentage, which was yearly in nature, which also had taken the compounding effect into the account. Return of the first month and return of the second month are not same. You must be aware about it. I hope you are aware about it. Because the 0.17 percentage of return, if you consider the second one, no, is not comparable to 0.14, because 0.14 was on 100 and 0.17 would be on 100.14. It's compounding. First month return is added to the investment amount, and on that you get the second month's return. Yes or no? So that's why we had multiplied this, all of it. And from there we had done -1. So we got the yearly return. Right? Okay. Now yearly return for all the number of years we had, for all the number of portfolios, we had three types of portfolio. One was aggressive, another one was balanced, third one was conservative. So we had found the yearly return of all of them by applying the same concept. I hope you are aware about it now. Then, I guess if I'm not wrong, we hadn't completed this too. Just a second. Yes. This average volatility, lowest expected return is 68% of the time, and highest expected return. Did we do that? I'm not very much aware about it. Can you just give me an idea about it? आपने ये सब कुछ कर लिया है? What is this lowest expected return in 68% of the time? It is also a part of the value of risk, value at risk only. Have you done it? कि नहीं किया था तो मैं करता हूं. I am actually not aware about it. That's why. किया था कि नहीं किया था? नहीं किया था ना? Okay, no worries. We would do it. Don't worry. Okay. So once the yearly return was found, up to yearly returns, everyone was there with me because that I remember. Okay, that we had done. स्नेहल yearly return तक हमने किया हुआ था ना? बाकी सब भी? चित्रा, ध्रुवी, all of you? In case if you are not aware about it, I would give you again a brief overview about that again. See, it was nothing but the product of all the monthly returns that was in hundreds you have got. What we had done was we had added 1 to that monthly returns, and then we had multiplied those. And from there, if you do the -1 and then you convert it into a percentage, you get the monthly return over there for all the number of portfolios. Okay, good. Now, once you have the monthly return, try to understand this particular table. Now, here, what is the requirement? First one is the average yearly expected return. Now, we have taken the number of months up to, I guess, 132. So that means it is the data of I guess, how many number of years? 12. So it would be, I guess, the data of 11 years, right? From the 11 years of data, we want to predict in the future too. This, say for example, this is the historical data we have, that what is our expected rate of return now based on the average returns we have got till now. So say average return we want to get, which is the yearly in nature, which is a very simple formula starting with the sign of equal to AVE RAGE plus to the average formula there, opening the bracket, and all the average returns you have for all the number of years, no? You'd be selecting right from the first to the last one. So say I'm there right now in cell number D14. So I'm doing control shift down arrow, control down arrow, sorry, control down, control down, control down, up to the point I have the last return, which is 5.44. Closing the bracket, pressing the enter. So you get the average return of the first portfolio. Right? In the same manner, you would also find the average return of the second portfolio. Everyone should start doing along with me. So it's nothing but just the average of all the yearly returns you have. So equal to AVE RAGE, opening the bracket. And right from the first to the last one, we are selecting all the returns there up to 9.58 in the second one. Closing the bracket, pressing enter. So second one average is coming at 9.07. Third portfolio's average equal to AVE RAGE, opening the bracket and selecting the yearly returns which is there in this column, J numbers column, selecting all and only up to the point of the last return, which is 16.08. Closing the bracket, pressing enter. So seconds average return was reaching to 9.9257 percentages. Is everyone there with me till now? So this is the average return given by the portfolio on yearly basis. Now here we are going to apply some value at risk principles. Once you are there with me in finding the average, we may move ahead. सब कोई साथ हो अभी तक? May I have a confirmation please from Mr. Joy, Krimi, Ms. Dhruvi, Ashwini, Bhavya? Okay, from Dhruvi, from Chandni we have got it, good to see. Okay, then it asks the volatility of the yearly return. Now volatility is nothing but the standard deviation, right? Standard deviation is the measurement of volatility. नाउ स्टैंडर्ड डेविएशन के लिए हमें अलग से फॉर्मूला जैसे मैन्युअली करते थे वैसा करने की जरूरत नहीं है. वी हैव द स्टैंडर्ड डेविएशन फॉर्मूला देयर. In the Excel, which starts with STDEV, 11 years of sample we have taken out of all the number of years of data we have. So STDEV dot S, opening the bracket. Now standard deviation formula is very easy. You will have to just select all the yearly returns you have, no? Right from the first to the last one. Again, shift page down I'm doing, and I'm selecting all the number of returns till the last one, closing the bracket, pressing enter. Now the beauty of Excel is, you people must be aware about it. You are not supposed to apply that formula again and again. You can just copy that. Everyone should try to focus over here. Copy this and paste it over here, because Excel changes its range automatically. See, it has taken the second range now. Now if I copy this, 7.29 percentage, copy this and paste it in the third portfolio, which is the volatility of the third one. So here I want the data, right? So what I'll do over there, I'll do Control V. Excel will automatically change the range of the data based on the formula we have applied. That's called the relative referencing. We are not supposed to do it again and again. So within just 2 minutes, what we have done, we have found the average return. We have also found the volatility. In other words, I can call the standard deviation of the returns from which we are supposed to find certain things. Till now, is everyone there with me?
Yes, sir.
Good. Thank you very much. Good. So I've received it from Ms. Dhruvi. We have found the standard deviation as well as the average return from all these three portfolios. Now we would move to the lowest expected return in 68% of the time. Sir, what is this? Okay, for that we'll have to again go to the standard normal distribution Standard normal distribution of the probabilities looks like this. If you can recall the bell curve which I had drawn last time around, I would again be repeating that. This is how it looks like. Say all the returns you have got. Now here is the average return, right? Now how the standard distribution looks like, try to understand that. See, here is the average return you have, and within a one standard deviation from that average, here you have 34% of all the returns. This is just a one standard deviation from average. So say for example, your average return is 8% and standard deviation is 6%. So on right hand side, which is a positive side, and if you add 6% into 8%, so that means it is reaching to 14%. right? So वैसे ही तुम्हें बेटा यहाँ पे एक स्टैंडर्ड डेविएशन लेफ्ट हैंड साइड में विच इज अ नेगेटिव साइड 1SD यहाँ पे करना है, तो इसका भी 34% बन जाएगा। यहाँ इस रीजन में भी 34% वैल्यूज आती है, but in negative side you reduce the standard deviation from the average. On positive side you add the standard deviation on the average. So if you reduce 6% from 8, so it reaches to 2%, right? 8 में से तुम 6 को रिड्यूस करते हो तो 2% से जाता है, तो आपको एक और रेंज मिल गया। 2% से लेके 8% तक आपके 34% ऑफ वैल्यूज रहने वाले हैं। तो इसका इंटरप्रिटेशन मैं ऐसे भी कर सकता हूं, 34 प्लस 34 मतलब कि कितने परसेंटेज वैल्यूज हो गई, 68% वैल्यू। That means in what probability distribution your return may go to the minus. What is the return range between just a one standard deviation away in left hand side as well as in the right hand side? Right hand side means you are adding to the average, left hand side means you are reducing from the average. So the simple understanding and the interpretation of this would be, if you reduce one standard deviation from the average, you get the minimum return in 68% of the times. And if you add one standard deviation in the average, you get the maximum return in the 68% of the times. Now, if you again stretch it further, no, in second standard deviation, here there is a 13% of the values lying. This is as per the standard normal distribution data. And here as well, there is a 13% of the values lying. And in rest of the region, you have 3 percentages. This is an approximation. Now you add 13 into 34. So what do you get? 94, 47, right? 47 on right hand side, 47 on left hand side. So 47 plus 47. So that is 94% of the probabilities. 94% of the distribution. So your 94% of the distribution would always be falling between two standard deviations. So that is 2SD here, 2SD here. So if I ask you one more question, try to understand and interpret it. If I ask you one more question, 94% of the times in the future, what will be my minimum return, and 94% of the times, what will be my maximum return? Try to understand this. So here you will be reducing the two standard deviations and you will be adding the two standard deviations rather than one, because now we have taken 94. So how can you do it? 8% minus 2 SD. So 1 SD it at 6%, right? So 8% minus 12%. So you get minus 4%, which is the return at the second standard deviation in negative side. And on positive side, you add to the average. So 8% plus 2 multiplied by 6%, right? So therefore 8% plus 12%. So that reaches to 20%. So I have got my range now. Now this range interpretation would be that in 94% of the times, my return would be falling from 4% to 20%. सिर्फ 6% प्रोबेबिलिटी ऐसी रह जाती है कि इससे एक्सट्रीम मूवमेंट आए, या तो फिर रिटर्न 20% से ऊपर जाएगा या तो फिर रिटर्न -4% से भी नीचे जाएगा. ऐसी प्रोबेबिलिटीज क्यूमुलेटिव सिर्फ कितनी है? सिर्फ 6% की. सिर्फ 6% ऑफ द टाइम्स में मेरा रिटर्न -4 से नीचे जा सकता है या तो फिर 20% से ज्यादा जा सकता है. इन ओवरवेलमिंग मेजोरिटी ऑफ द 94% ऑफ द रिटर्न्स, my return would be falling in this range. Is it clear to everyone now? This is a very, very practical concept, because when you prepare the portfolio management of any person, you know, if we allocate some portfolios, at that time we need to first see that what is the risk taking capacity, whether he has the risk bearing capacity of 4% return, yes or no. And if the standard deviation would be low, no, and average would be high, so at that time what will happen, that at second standard deviation return will not go into the minus. So those would be the very stable kind of a portfolios. So if person's risk taking capacity is not that much, I would suggest him that much. And lower the standard deviation, obviously the upper range will also be limited, and because of that your maximum return might also not be that much. So higher the risk, higher the return, you know. स्टैंडर्ड डेविएशन लो होगा तो अपर साइड पे भी इफेक्ट आएगी ना, जैसे लोअर पे आती है. तो चलो यहां तक सबको ही क्लियर है, तो मैं अब आगे बढ़ूं. एवरी वन ऑफ यू, एक छोटा सा कंफर्मेशन हो जाए, छोटा सा, सिर्फ इत्तू सा यस सर और डन सर वाला. फ्रॉम चित्रा वी हैव गॉट, फ्रॉम चांदनी वी हैव गॉट, अदर्स आई एम वेटिंग फॉर योर रिप्लाईज. चलो बेटा मेरे साथ हो सब कोई, क्योंकि मेरे को क्या प्रॉब्लम होता है ना, मुझे मालूम नहीं है कि बच्चे कर रहे हैं साथ में कि नहीं कर रहे हैं, समझ में आ रहा है कि नहीं आ रहा है. चलो ध्रुवी भी डन है, गुड टू सी दैट. मिस नेहा टू, वेरी गुड. Now this distribution is applicable only if you assume that the data is normally distributed. And if you do not have the assumption of normal distribution of the data, then you may find it on historical basis. I'll let you know. उसको historical basis पे कैसे find करना है वो मैं आपको बताता हूं. तो यहाँ पे आप सब लोग मेरे साथ क्या करोगे, मैं पहले तो है ना इसको डिलीट कर देता हूँ. डिलीट करूंगा ना तो ही बच्चों को अच्छी तरीके से मालूम पड़ेगा. मैं सब दोनों को डिलीट कर देता हूँ, मैक्सिमम एंड मिनिमम तीनों पोर्टफोलियो को इधर से. चलो अब मैं क्या कर रहा हूँ, कौन बताएगा? लोएस्ट एक्सपेक्टेड रिटर्न इन 68% ऑफ द टाइम्स, दैट मींस आई नीड टू रिड्यूस माय स्टैंडर्ड डेविएशन फ्रॉम द एवरेज, राइट? And when I want the highest expected return, in 68% of the time, that means I need to add one standard deviation in the average, because highest would be on the positive side, lowest would be on the negative side of the normal distributed data. So equal to average minus SD, which is the standard deviation. Pressing enter. And highest would be equal to average plus standard deviation, average plus standard deviation. So you get 14.37 percentage. I'm just copying that formula because Excel uses the relative referencing, right? I'm copying that and pasting it over here. Again, in the third portfolio, I would copy and paste it over here. Now this was in the percentage terms, right? You may convert it into the rupee terms as well. We will see that in the rupee terms हम कैसे convert करें. सबका एवरेज SD 68% प्लस 68% माइनस ये हो जाए तो मुझे बता देना. आगे बढ़ू मैं. कि थोड़ा सा देर रात देखो जैसे आप बताते हो. कर रहे हो तो मैं वेट करता हूँ, डो नॉट वरी. हो गया तो बता दो प्लीज. May I move ahead, all of you? Dhruvi, Sneha, Chitra, good. Thank you. So what we'll do, we would also find it in the rupee terms. Now to rupee terms, we need to first see that what is the amount of portfolio we have invested. Till now, we have just found it on the return basis, right? Say client number 1 had invested 60 lakhs rupees in this portfolio, 2 had invested 80, and 3 had invested 3 crore 70 lakhs. So average return can be the amount of portfolio that you have invested, that is 60 lakhs, multiplied by the average return. So I'm selecting that cell now. Again, I'm doing it for your reference. Equal to the cell where the wealth amount is written multiplied by the average return I have got, which is 8.44%. Pressing enter. Right? Now again doing equal to 60 lakhs multiplied by 5.92%. So equal to, so I have got the standard deviation now in rupee terms. तो मेरे पोर्टफोलियो में हर साल का मैं स्टैंडर्ड डेविएशन 3,55,414 रुपए का एक्सपेक्ट कर सकता हूं वोलेटिलिटी ऑन एन एवरेज बेसिस. अब ये एक एक को करना तो सर हमारा एक्सेल के नॉलेज की इंसल्ट हो जाएगी. क्या हो जाएगी? एक्सेल के नॉलेज की इंसल्ट हो जाएगी. तो हम क्या करेंगे मालूम है? अपन को है ना ये सेल चेंज होते रहना है. कौन सा वाला सेल चेंज होते रहना है? बी वाला. The B line must get changed. So for there we want the relative referencing only. But this amount of wealth should not change, right? For that we want the fixed referencing. So what can I do is, which is there in the C and 5, no? We would go between C and 5 and we would press F4 there. So the dollar sign would have been inserted. That means that cell is fixed now. Excel will take 60 lakhs only in every case, whenever you will be copying and pasting that data. So I'm doing enter. Relative referencing is there in the percentages, and for the amount we have taken the absolute referencing. Now if you copy that, oh ये क्या हो गया, हाँ आ गया. Now if you copy and paste it to other cells, no, all other amounts would be adjusted automatically. It will always take that 60 lakhs rupees as the fixed reference, and the amounts will be changed. Sorry, percentage would be changed, and accordingly the amounts would be changed. So what is the interpretation of this? Everyone try to understand. Lowest expected return at 68% of the times. In return, it is coming at 151, 187. So we may say to the client, those who are coming to us for the portfolio management, say like in 68% of the chances, your return can go to negative. Sorry, your return can be as low as 151, 187 from your entire portfolio in the year. It is not still going in the minus. At 68% of the time, it's positive only. And we may say that to them that maximum return in 68% of the time will be 862,016,19. In the same way, we would also find it for the portfolio of client number 2 and portfolio of the client number 3. So equal to, I'm selecting this wealth, and this cell needs to be fixed. So what I'm doing is between F and 5, I'm pressing F4. So the dollar sign is inserted, multiplied by this percentage of returns you have got, right? Pressing enter. Now just copy and paste it to other cells, other 3 cells. You get the amounts in percentages. The interpretation of the amounts would be in second one. In second one, if you see, no, the range of the variation is very high as compared to the first one. The lowest return in the first one was 151, but the lowest return in the second one may go to 141 too, which is just a difference of 10,000. But in the difference of 10,000, if you see, no, the higher range is getting increased to 13 lakh 08. So at upper side you have 5 lakhs rupees of return increased, but at the downside of 68% of the times you have just 10,000 rupees of reduction. I think the second one looks very, very rational. The second one looks very, very promising. The reason why it looks very, very promising, because just by taking some additional risk, your lowest return in 68% of the times is falling just by 10,000, but the maximum return may go as high as 13 lakh 08. Now this happens because you have the different amount of wealth. That's why amount of wealth is different. That's why. But in percentage terms too, you may compare it. See, 252 का कहाँ पे जा रहा है, 177 पे जा रहा है, लेकिन 14.37 ऊपर जा रहा है 16.36% से. अमाउंट अलग है तो फिर डायरेक्ट नंबर्स को अपन कंपेयर नहीं कर सकते, क्योंकि हर एक का वेल्थ अलग अलग है ना, इसलिए. लेकिन परसेंटेज को कर सकते हैं अपन कंपेयर. परसेंटेज में रिडक्शन कितना आ रहा है देखो, 2.52 से लेके 1.77. सो अप्रोक्सीमेटली 0.75% का रिडक्शन आ रहा है. लेकिन तुम्हारे हाईएस्ट रिटर्न में एडिशन 2% का हो रहा है. रिडक्शन सिर्फ 0.75% का, लेकिन एडिशन हो रहा है 2% का इन 68% ऑफ द प्रोबेबिलिटीज, विच इज अगेन अ गुड साइन. And once it is done, then you may go to the third one. third one is not 0. There would be some amount over here, but it's because of the decimals we have got over here, because standard deviation and average both are coming nearby. So let me increase the decimals a bit so you get the returns there. Check it. I hope you have got the interpretation of this. Is everyone there with me till now? All of you? आगे बढ़ूं मैं? Okay, from Chandni I've got, good to see that. From Chitra too, good. From Dhruvi too, very good. Okay, but if I ask you now this is, just using the standard normal distribution. But if I ask you a very specific question, that what is the maximum loss I can make at 95% of the confidence? In 95% of the times, what is the maximum loss I can make? If I ask you this kind of a question, then what? Or if I say that what is the maximum loss at 10 percentage, at 90 percentage of the times? Here you have got the times, which is 68 percentage or 94. But if I give you a very specific percentage of the probability, कि 5% प्रोबेबिलिटी ऐसी होनी चाहिए कि जिसमें वो रिटर्न है वो उससे नीचे जाए, 95% प्रोबेबिलिटी ऐसी होनी चाहिए कि उससे रिटर्न ऊपर हो, ऐसा मैं पूछूं तो तुम कैसे करोगे? तो ऐसा पूछूं उसको ही तो वैल्यू एट रिस्क कहते हैं। और वैल्यू एट रिस्क में तुम दो अप्रोच से सोल्व कर सकते हो। हमने मैन्युअली किया है, एक्सेल में कहना बाकी रह गया था। पहले तो तुम अज्यूम करो कि भाई डेटा है वो नॉर्मली डिस्ट्रीब्यूटेड है, ठीक है? और नॉर्मल डिस्ट्रीब्यूटेड अगर डेटा नहीं है तो फिर तुम्हें एक्चुअल हिस्टोरिकल फिगर से जाना पड़ेगा। तो ज्यादातर केस में, ओवरवेलमिंग मेजोरिटी में डेटा नॉर्मली डिस्ट्रीब्यूटेड ही होता है। रिटर्न का कैलकुलेशन के अंदर एक बेसिक फंडामेंटल हम अजम्पशन लेके चलते हैं कि डेटा है वो नॉर्मली डिस्ट्रीब्यूटेड है। लेकिन अगर नहीं भी लेते हैं, उस अजम्पशन को वायोलेट भी करते हैं, तो हम हिस्टोरिक बेसिस पे फाइंड कर सकते हैं कि 5% में अभी तक कितने रिटर्न फॉल होते हैं, लोएस्ट 5% में, और ऊपर के 95% में कितने रिटर्न फॉल कर सकते हैं। तो मेरा मैक्सिमम लॉस कितना हो सकता है एकदम अंत वाली 5 वाली परसेंटेज में? सो दैट मीन्स आई एम 95% कॉन्फिडेंट कि मेरा जो लॉस होगा ना उससे ज्यादा नहीं होगा। I hope you are able to understand my constructive arguments here. If I give you one more question, find the value at risk at 6%. So what is the meaning of 6%? That means there would just be a 6% values below that particular return and 94% of the values which should be above that return. Same way, if I ask you, say just 3% VAR, that means 3% of the returns would be below that and 97% would be above that. So I can say that 97% confidence is there that my return won't be falling between, won't be going below this particular value at risk. तो वो वाला रिटर्न परसेंटेज फाइंड करना ना, उसे ही हम वैल्यू एट रिस्क कहते हैं। एक्सेल के अंदर बहुत इजीली हो जाता है ये, बहुत इजीली। अब उसके ऊपर मैं अभी नहीं आ रहा हूं क्योंकि इट्स ऑलरेडी 12:22, राइट? बिकॉज यू पीपल might be little bit tired as well. So that will be solving in the next lecture. But I hope you are getting my argument. So I have repeated the things we had done last time around because there is a quite a few number of days that has passed between this holidays and all sorts of a thing. But next lecture के अंदर से हम ये वैल्यू एट रिस्क कंप्लीट कर देंगे और फिर अपन थर्ड मॉड्यूल में चले जाएंगे। आर्बिट्रेज प्राइसिंग पॉलिसी भी करना है, वो थर्ड मॉड्यूल के साथ ही कर लेंगे क्योंकि वो पोर्टफोलियो मैनेजमेंट के पार्ट में भी कवर कर सकते हैं। ओके, So I'm just sharing the attendance with you. I hope you are absolutely clear about all the things you have done till now. We have done till now. In case if you have